Vlan hopping is a security exploit attacks network resources on a Vlan. It is for a attacking host on a Vlan to gain access to traffic on other Vlans that would normally not be accessible. So here in this Wikipedia article, it talks about two primary methods to do Vlan hopping: switch spoofing and double tagging. I'm going to cover Vlan hopping and UniFi switches in two separate videos. This one you are watching is for the first method, switch spoofing. As explained in the Wikipedia article about switch spoofing, so the attacker imitates a trunking switch and speaks in DTP or dynamic trunking protocol so that it can spoof the switch to open up a switch part in trunk mode. However, as I know, UniFi switches do not support DTP, so I am not aware of a way to dynamically ask the UniFi switch to change the switch port setting to change the port mode from access mode to trunk mode. So on one hand, the title for this video is kind of like clickbait because I'm not going to show you how to do switch spoofing for UniFi switches. But on the other hand, what's the reason for the attacker to do switch spoofing is to achieve trunk mode for a given switch port, right? You may know UniFi switches have a potential security risk. By default, all the switch ports are working as a trunk mode. Basically, the native network is default network, VLAN 1, and then it allows all other tagged VLANs. To put it the other way, even without doing any switch spoofing, the attacker can already do the harm if you don't change your switch port. So in this video, let's talk about the details. In my lab environment, I have two UniFi switches, a Pro 24 and a Pro Max 24. I connected a Linux virtual machine to each of them. So I'm going to use the upper one as a victim machine, the lower one as the attacker. In the right side, you can see in UniFi Network Controller, I have VLAN 88 and 66. For VLAN 88, I name it as a super secured VLAN, and then for 66, it's a insecure VLAN. Then in security setting, I already configured a firewall rule to drop the traffic from VLAN 66 to 88 because I don't want insecure network to access my secure network, right? So it seems the 88 is well protected by this firewall rule, right? But you may care too much about the firewall rules but ignore the switch port setting. So you may end up with some potential security issues. Let me go to the Pro 24 switch. So I connect the victim computer to the port 26. You can see the native VLAN is 88, the super secured one. And then for tagged VLAN, I set it to block all. So basically now this port is acting as a access port. It only allows the untagged 88 VLAN traffic. Then if I go to the Pro Max 24 switch, for the port 24, you can see the native VLAN is 66. And for tagged VLAN, here I simply want to show if you don't change the switch port setting, you leave the default allow all setting, what will happen? Then because now we are talking about two switches, to link these two switches, if I check the port setting between the two UniFi switches, for example this one, you can see it's the default setting. So the native VLAN is default network, then tagged VLAN is allow all. That's the typical trunk port setting to link two switches. Okay, during the testing, I want to use two Wireshark sessions to monitor the traffic for the victim part and the attacker part, just to better understand what's going on under the hood. Okay, so now let's get the attacking started. Let me get the IP addresses for the two Linux machines first. The attacker is in subnet 66, so it's in VLAN 66. And the victim machine is in subnet 88 because the access part has the native VLAN 88. Then from the attacker, let me try to ping the victim machine. Before I kick off the ping, let me start the Wireshark monitoring, start capturing in both Wiresharks. As you can see, I already set the display filter for the Wireshark to ICMP. So now they are not showing anything. Now I'm ready to start the ping from the attacker machine. Okay, you can see in the left side Wireshark it's capturing each request, but in right side nothing's happening. The reason is we have the firewall rule, so when the packet was routed to the gateway or router, it's simply dropped. So that's why the ping is not successful, which is expected. We are good, right? But if just because this ping failed, you think your network is secured, you are wrong. The reason is your attacker's port is set to trunk mode. The attacker can easily use other tagged VLAN to do whatever they want. Let me simply show you. So from the previous command, we know the Ethernet interface name is called ENS18. Then let me create a VLAN interface on the fly. Let me run the IP link command. What I'm saying is I want to add a new link based on the existing ENS18 interface and give it a name ENS18.88. This is a naming convention for a VLAN interface. .88 means it's for VLAN 88. Then the type of the new link is VLAN interface and the VLAN ID is 88. Okay, now I have a new link, but it doesn't have a IP address yet. So let me simply assign a fixed IP address. I use command IP address, add a new fixed IP address, 88.88 for device ENS18.88, which is the one we just created. So now we have a new link. It has a IP address, but we cannot use it yet because we haven't brought it up yet. So we can simply bring it up using the command IP link and set the newly created interface, and I say up. Okay, so now the link is up. Just to validate, we can show the current IP address. Now you can see for this newly created interface, the status is up. It has this static IP address, right? Now let's test whether we can access the super secured victim machine. And to make sure, I'm using the newly created interface. When I run ping, I say -I, then specify the IP address for that new interface. Then I ping the victim's IP address. Okay, see, it's successful. So let me stop the ping. Then let's see in Wireshark what's captured. So let me pick a random packet. If you compare this one with previous one, before we add a new interface, let's check a previous one. It doesn't have a VLAN tag section. But for the new ones, see this section, the VLAN tag, if we expand it, it says VLAN ID 88. Why? Because we did the ping through the new VLAN interface and the VLAN ID for that interface is 88. So that's why the packet which is coming into the switch has the VLAN tag 88. And because the port is a trunk port, the 88 is allowed. Then the switch will forward the 88 packet directly to the port for the victim machine. It doesn't need to go to the firewall because it's in the same network, the same subnet, so the firewall rule won't be effective for this situation. So the packet was directly forwarded to the victim port. In the victim port side, there are some interesting things happening. So there are two types of packets. See the request packet, which was sent from the attacker machine to this victim machine, right? It does have a VLAN tag section, and the VLAN tag is 88. But if you check the reply packet, which is from the victim machine back to the attacker machine, see, it doesn't have VLAN tag. Why is that? Why the difference? Let's go back to the UniFi network controller. For this port 23, which is the victim part, even though now I set it as block R, But let's say if I do want to selectively allow some tagged VLAN, then I say custom, and then I have the select button, right? Let me choose it. See what VLANs are listed. You don't see VLAN 88. Why is that? Because VLAN 88 is the native VLAN. So this type of display already implies VLAN 88 is allowed anyway. The reason is the VLAN 88 is the native VLAN. So to put it the other way, even though now the port 23 is set as a access port, even though we only say we want to have the untagged VLAN for the native VLAN, which is 88, right? But it implies it also allows the tagged VLAN for VLAN 88. Okay, go back to the Wireshark. So that's why here, even though the port received a tagged VLAN packet for VLAN 88, it is allowed. So the switch will not drop it. So the switch will still forward this packet to the switch port. And then when it comes to the reply packet, which was sent by the Linux machine, right? Because the Linux machine doesn't know the VLAN. We simply wanted to support the untagged VLAN for VLAN 88, right? So that's why the reply doesn't have VLAN tag. But if we go back to the left side, when the reply reached the attacker machine, see, it does have VLAN 88 because this attacker part is set as trunk part and the VLAN 88 is tagged. So the switch will automatically add the VLAN tag for VLAN 88. That's why for the same packet, depending on from which port you see it, you may observe different VLAN tag information simply because of the switch port setting. We had two Wireshark sections, right? So the top right one was mirroring the victim part, but it reflects the situation before the packet was forwarded out of the port. To make it more interesting, let me launch a new Wireshark for the bottom right. It will capture the packets from the Linux machine perspective. Remember, in the victim Linux machine, the existing network interface, it doesn't have VLAN tag, right? It is supposed to capture everything received in the switch port. So let me try it. From the attacker machine, let me ping the victim machine again. Okay, see, packets are being captured in all three Wireshark sessions, right? Stop it. From the switch perspective, before the packet was out of the switch, see what's the request packet look like? It does have a VLAN tag for VLAN 88, right? But let's see what's received by the Linux machine. See, it doesn't have VLAN tag anymore. So the VLAN tag was not removed by the Linux driver because, as I said, the network interface doesn't have a VLAN tag setting. So the fact that this request packet doesn't have VLAN tag simply because when the packet was out of the switch port, it didn't come with VLAN tag. So see the difference before it was out of the switch port and after it's out of switch port. See the interesting difference? Okay, I just want to briefly mention the interesting difference for the switch port when it comes to VLAN tag. Okay, go back to original topic. In this simple way, we successfully accessed the super secured network even though you have the firewall protection for it. Okay, so now you see the attack in action already, right? Don't think this type of activities in the attacker machine can only be done by some experienced hacker. If you are interested, check my video about for different operating systems, how to set up VLAN interfaces. You will be surprised about how easy it is to access the tagged VLAN if your port is a trunk port. It's time to talk about how to prevent this type of VLAN hopping. The solution is very easy, but it requires your time and your patience. If the port is only intended to connect to a device or a computer, which only require access to one particular VLAN, you need to set the port to to a access part instead of a trunk part. For example, for the port 24, it is used to connect to the attacker computer, right? So see, the attacked VLAN management is set to allow all. This is the default setting. Because of this, now the port is acting as a trunk port, but you don't really need trunk port because the computer only need to access VLAN 66, which is already indicated in the native VLAN, right? So you simply choose block all. That's it. We can validate the effect from the attacker computer. I still have the newly created VLAN interface for VLAN 88, right? Let me run the exact same command to ping the VLAN 88 victim machine. From the Wireshark, you can see the switch really received the tagged VLAN packet from the computer, which is for VLAN 88, but it simply dropped the packet because we set in the port profile that it doesn't allow tagged VLAN. So that's why the packet was never able to reach out to the victim machine. Okay, now you see the effect, right? Even though this type of access port setting is simple, you need to do it in this way for every part. It's a time-consuming process. Okay, this is about access part. But you know you need to connect different switches, right? For example, this port 25 and port 26, they are used to connect UniFi switches. So they need to be set as trunk port, which means here I say tagged VLAN management allow all. Another example case for trunk port is, for example, this port 1 for this 8-port enterprise switch. It is connected with a access point. Depending on the usage of your access point, you may want to keep it allowing all tagged VLAN, or you can customize the VLAN selection depending on your usage. Okay, then of course, if you have some servers which need to provide services to multiple VLANs, then of course you need to set the port as trunk port as well. So depending on the usage of the device, you need to choose whether you want it to be a access port or trunk port. I don't want to talk about the details about UniFi switch port mode, for example, access mode, trunk mode, general mode. If you are interested, check the existing video in my channel. Regarding setting up tagged VLAN management for switch port, there's some special situation for UniFi switches. For example, this USW Flex mini switch is a very cheap switch, and because of that, it misses some features. If you want to set it as a trunk port, because anyway it need to connect to some uplink switch, right? If you keep the native VLAN as default network, yes, for tagged VLAN you can allow all or block all, but you cannot customize it. That's not a big deal, right? But if, for example, the port 5, I want to have the native VLAN 66, not the default VLAN. See what happened? For tagged VLAN management, you cannot allow all. You have only one option, which is block all, which means if you want to have a native VLAN, which is non-default network, it has to be an access port. Just some very detailed differences or missing features. Maybe it doesn't matter to most people, but I just want to point out here. Okay, so this is the end of the video. Keep in mind, this is just the first half about VLAN hopping. In my next video, I'm going to talk about double tagging. Okay, thanks for watching.